Hello, folks. Now we're going to do the slide that I've been talking about, and that is friction. Now let's go ahead and work on some of the terms that we need to talk about before we hit friction. First is the term weight. And we always have a bad habit of equating weight with mass. And that is not exactly correct. Weight, by definition, is the force of an object on a surface due to gravity. So as I'm standing on a scale, it's actually measuring the force. That scale is a spring-loaded measurement, and it moves a dial. And it's basically saying that how much force my body's applying onto that scale. And the actual imperial unit for force is pounds. So our weight is equal to mass times acceleration, where the acceleration is 9.81 meters per second squared, which is our acceleration of gravity. So when we talk about weight, we're talking actually the force on a surface. And so if we look at this, again, to reiterate, we have a surface, we have a force, and we're talking about a horizontal surface at the moment. And this force is exerting so much, this object is exerting so much force onto the surface. And this is what we call weight. Again, we've got a very bad habit of equating weight with mass, even though it's not exactly true. Now, normal force is a force acting on force of a surface acting on an object. So we have, remember Newton's third law, for each reaction you have an equal but opposite reaction. So we have, here's our dot, we got our weight pushing down on the surface. The surface is going to reply with an equal but opposite reaction. And since it's not moving anywhere, these two values are going to be equal. And the fact that it's a normal force means that it is perpendicular. It forms a right angle with the surface. But if we change the angle, and here's our block, there's our weight straight down on the y-axis, but our normal force is perpendicular to the surface, and it's this. So this is the normal force. Why is this important? Because what's pulling, the force that is perpendicular to the surface is not the weight of the object. It's a part of that. So the normal force is actually less than the weight because it's not horizontal. This is important because this is going to dictate how things move up and down on a plane or on a ramp. Because now we have frictional force. It's actually opposite of motion. So if we got an object again on the table, and it's going to be, if I'm pulling this way, so here I am, I'm pulling this way, friction is in the opposite direction. And the amount of friction is going to be dependent on the following. And we'll start from the bottom, the composition of the surface as an object. So you got, object has a surface, so I've got a flat piece here, and the surface is flat. What it's made out of is going to dictate how much friction you're going to have. Stainless steel will have a different type of friction than rubber or ice and so forth. So the actual composition of the surface is going to dictate how much friction. Also, with that is the weight of the object on the surface. Increase the weight on the surface, you're going to increase the amount of friction. And the smoothness of the surface. So how smooth? You can have two pieces of metal that are rough. It's going to have a different amount of friction if you smooth it down and make it shiny and smooth. Frictional force. All depends upon these three items. And we're going to have two different types of friction. We've got kinetic friction, which is involved in the object moving, and static, which keeps the object at rest from moving. Now, static friction is different from inertia. I want to bring that point out. Static friction and inertia are two different things. And to lay the point, if we got a block in the middle of space with nothing around it, and I try and push it, it's going to have inertia. It won't move unless I really apply some force. Now, if I have that same block on say on a piece of ice, it's going to, not only do I have inertia, but I also have friction going opposite the way I'm pushing or pulling, and it won't move. Now, by definition, kinetic friction, which is the friction involved with an object moving, is always less than static. Because what's happening, if we increase the force and it doesn't move, as soon as force reaches to a certain point, the object's going to start moving. Then it's going to go down, and we're going to end up, the force is going to become constant. This is static, and this is, if we keep a constant velocity, this is going to be kinetic friction. We can actually measure that. And we have a lab involved in that, and we may do that lab by video later on in a couple weeks. Now, last thing is the coefficient of friction. The coefficient is when you got two things, pair of materials touching each other, they're going to have some type of coefficient of friction. Where this coefficient is the force of friction divided by normal force. But here's the thing. Remember we talked about this? Here's my normal force. This is gravitational, or the weight. Friction is going this way. If we have a ramp, normal and friction are actually going to be up at an angle. So this is what we have to do to make it easy for ourselves, is to rotate our perspective so only one thing, the gravitational pull, is at an angle. And here's my angle. So these two are x and y. And this is how we solve these type of friction, especially when we're talking about trying to get things moving down a ramp. Now, in this case, the normal force is going to be a little bit less than it is if it was on a flat surface. And that will always be true. So, this will be a constant for whatever materials we have, whichever material pair. This is going to be set. This is going to be, these can change based on this and this. If this is static or kinetic friction, or if the normal forces change. So that's one thing you need to realize when we're talking about this set. And that is it for my presentation. Have a good day, folks.